Welcome to ClickMyProject.com. Let we discuss about the process three-dimensional data-driven multi-scale atomic representation of optical coherence tomography. Let me see the abstract of the process. Enhancement of images will be more helpful in medical applications in order to identify the different regions in the medical images. In the enhanced images, the affected portions were more clearly visible. The denoising process removes the unwanted pixels in the medical images so that the organ portions and the disease affected were identified exactly in the images. The defects in the images can be identified based on the features extracted from the denoised images. The noise commonly occurring in OCT images were salt and pepper noises, Gaussian noises, a process that identifies the noises in the medical regions and removes the noisy pixels based on the KSVD denoising process is proposed. The denoised images were then clustered and the edge regions were identified in the medical images. The input OCT images were taken. The noises were added to the input images, producing the noisy OCT images. The input images were denoised based on the KSVD process. KSVD is a generalization of the K-means clustering method, and it works by iteratively alternating between sparse coding and the input data based on the current dictionary and updating the atoms in the dictionary to better fit the data. It aims to partition in observations into few clusters in which each observations belongs to a cluster with the nearest mean, serving as prototype of the cluster. The denoised images were then clustered and edges of the clusters were identified. The clusters were estimated based on the LCM clustering process. The edge regions of the different portions in the images were identified and they were marked. The defects in the images were identified based on the statistical features extracted from the images. The statistics used for the extraction of the features were mean, standard deviation, and the variance. The extracted features were then classified using KNN classifier in order to identify the defects in the images. The performance of the process is measured using the performance metrics like PSNR, MSE, and SSIM of the input and the denoised images. Let me see the flow of the process. The input OCT images were taken. Noises were added to the OCT images, resulting in the noisy OCT image. First, the dictionary is formed. In the dictionary formation step, the artifacts in the images were identified. The sampled images were divided into 8x8 process. The constraint optimization process, the relationship between the original pixel information and the magnification rate can be identified. From that, the sparse matching process is employed. In the sparse matching process, the identified noises were matched, resulting in the exact identification of the noisy pixels in the input images. Finally, the KSVD denoising process is employed. KSVD is a generalization of the K-means clustering method, and it works by iteratively alternating between the sparse coding, the input data based on the current dictionary, and updating the atoms in the dictionary to better fit the data. It aims to partition in observations into few clusters in which each observation belongs to the cluster with the nearest mean, serving as the prototype of the cluster. The clustering method is based on the identification of the difference between the input data and based on the difference the clusters were assigned. By comparing the dictionary patches, the original patches, the noises in the images were estimated. The estimated noises from the images were removed, resulting in the denoised OCT images. Then clustering process is employed. The regions in the images that were having similar intensity is clustered using the fuzzy C-means clustering algorithm. Any point in the image that has a set of coefficients giving the degree of being in the kth cluster with K. Fuzzy C means the center of the cluster is the mean of all the points weighted by the degree of belonging to the cluster. Each cluster region represents the regions the different density. Finally, the edge of the cluster regions were identified. The features were extracted from the edge detector regions based on the statistical parameters like mean, standard deviation, and the variance. The features were then classified in order to identify the disease in the whether the input image is disease affected or not. And finally, the performance of the process is measured in terms of the PSNR, MSE, and the related values. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is present in the data source code folder. Right click it and click on run file. You will get the process executed. First select any one of the OCT image. The input image the process will be executing. This is the input image that we have selected. The noise is added to the input image and the initial dictionary is generated for the identification of the noisy pixels in the image. This is the KSBD dictionary generated with which we identify the exact noises and remove the noises. This is the denoised image obtained. Thus, we have removed the noise added to the input image based on the KSBD denoising. This is the overall clustered region in the input image. From this, we separate the input image into several regions. So this represents the several separate regions in the input images. So the clustered edge regions were displayed in the images. Hence, we have identified the exact edges of the input images. So this is the separate regions identified. So as a result of the clustering process, we separate the input images into several regions. These are all the performance measures measured for the process PSNR, CNR, TP, EP, and ANR. These are the performance measures. The PSNR for the noise image and the designed image were also measured. Thus, we have removed the noises in the input OCT images, and we have clustered the input OCT images, and we have identified whether it is normal or disease affected images. So the input image is normal. The proposed approach performances indicates that the proposed approach is more improved compared to the other existing approaches.